Good day, everyone. So the topic that I will be discussing today is about potential energy and energy conservation. So these are the topics to be discussed: gravitational potential energy, elastic potential energy, conservative and non-conservative forces, and lastly, conservation of energy. Let's first discuss what is potential energy. So the definition of potential energy is that the potential energy is the energy associated with the position. With the position. There are many types of potential energy. So one is called the gravitational potential energy. So first, let's print screen this following figure. Okay, uh, and let's download pictures. Okay, so let's first cut this off. Mhm. Okay, so consider this block moving from position y y1 above the ground to position y2 above the ground. So let's first draw some horizontal lines. Okay, so and then so now let's say this is y equals 0, this is y equals y1, and this is y equals y2. And now let's say that the object is initially at point y1, so with mass m. So the question is, what is the work done by gravity in moving this block with mass m from point. Okay, I think I should write this as this must be y1 and this is y2. So the question is, what is the work done? What is the work done on the gravity in moving this block from y1 to point y2? So from here. So accordingly, the definition of work. So the work is just F equal to F that dl. So okay, and the gravitational force. So let's emphasize that this is the work done, the force of gravity. So Fg, and this is the work done by gravity. The gravitational force is equal to the mg, and the direction is along the negative j hat. So this is negative j hat. So that product with the displacement vector. So the length at which the object travel is equal to y1 minus y2, and the direction is along the negative j hat. So this is negative j hat. And we can write this as mg y1 minus mg y2. Okay, so now this mgy is what we call the gravitational potential energy. So the gravitational potential energy, which will which we will denote as u sub g, is equals to mgy, where y is the position. So which means that the work done by the gravities can be rewritten as u1 minus u2. So the work done by the gravity in moving the object with mass m from point y1 to y2 is just equal to the potential energy at the point y1 minus the potential energy at point y2. And this u sub g, which is equals to mgy, is just the gravitational potential energy. And okay, so let's move to another type of potential energy, which is the elastic potential energy. So again, let's print screen this following figure and let's go to paint. So okay, oh, Okay, so now consider a spring. A spring is not a spring, ano, no? So initially the spring is at equilibrium. So the equilibrium of the spring is, we say that the equilibrium spring is when this is at x naught. So this is x naught, and let's say that this is point x1, and this is point x2. So accordingly, the force exerted by a spring is not a constant, but a varying force. So the work done is just the, so if you have this type of force which is varying, then we say that, I will write it here, that if this is the varying, this function corresponds to the varying force, this is y. So, and this is the point x1, and this is the point x2. So accordingly, the work done is just the area under this curve between the point x1 and the x2. So this is the work done with the elastic force. Okay, so suppose this is the equilibrium position of the spring is when this is at some point x, say x3, and the one endpoint is the point x naught. So suppose we compress. So suppose that the spring is initially compressed at point x1. So this is x3, and this is here. This is here. So the spring is initially compressed at point x1. So the question is, what is the work that must be done to the spring to compress it more from? So kung ato pa yung i-shock i-compress, naka-compress na siya daan, kaya ang iyang equilibrium position kinama sa x naught. Suppose ako pag siyang i-compress. So, pila ang work done nga akong kinahanglan para ma-compress pa gid akong spring from point x1 padulong pa sa x2. So, in this case, that the work done, as I mentioned earlier, so let's emphasize that this is elastic. This is just equals to the f of x dx. So, from x1 to x2. So, this is just the area under the curve of this function over here from point x1 to x2. So this is just equals to kx, right? So integral from x1 to x2, and this is kx dx. So this is just equals to 1/2 kx2 square minus 1/2 kx1 square. So by the way, this kx squared is just what we call the elastic potential energy. So the elastic potential energy is given to be equal to 1/2 kx squared, which means that the work done in compressing the object from point x1 to x2 is just equal to the potential energy at point x1. So I denote this as 1 minus the potential energy at point 2. So this is u1 minus u2. So the work done by the elastic force in compressing the spring from point x1 to x2 is just equal to the potential energy at point x1 minus the potential energy at point x2. Okay, so let's move on. By the way, there are some problems, but Um, we will answer it after we discuss about the conservative force. So first, okay, so there is some question. Question one: is potential energy associated to all type of forces? So the answer is no. So the only for conservative forces. So dili tanang energy, dili tanang no, dili tanang forces na ay corresponding potential energy. So katulang mga forces nga gitawag og conservative forces. Of course, as we discussed earlier, gravitational force has some potential energy, which means that gravitational force is a conservative force, and also the elastic force is also a conservative force. Okay, so what is conservative force and non-conservative forces? So if the force is can be written as the gradient of the potential energy, or can be written in this expression: negative partial of u over x I hat plus partial of u over partial of y g hat plus the partial of the potential energy of with respect to z k hat, or more more elegant way to write this is we write this as the negative gradient of the potential energy. So if we can rewrite the force into this following expression, then we say that that force is a conservative force. So example of that is the gravitational force. So first, let's first atos na talahon kung conservative force ba gining, for instance, kining gravity. Okay? So, okay, let's rewrite this one. Atos na ning i-rewrite. So, okay. So remember that the force of the gravity is given by, so if we write this vector, this is negative mj, and this is along j hat. And as we mentioned earlier, that the gravitational potential energy is actually equal to mg multiplied by y. So now, remember that we can rewrite the force of the gravity. So we will try to rewrite the gravitational force into this following expression: the partial of u over partial x I hat plus the partial of u over partial of y j hat plus the partial of u over partial of gk hat. So which means, so we can rewrite this this way. So negative, and this is d, okay, the mg y. So with respect to x I hat plus the partial with respect to the y-axis. So this is m gy, okay, and this is along the j hat. So plus the partial with respect to dz, and this is mgy, and this is along the k hat. Okay, so that's okay. So by the way, if we kung ato ning tanawag maayo, we say that this first term is actually equal to zero, right? So m, g, y are just constant with respect to x. But the second term is just mj, right? Mj j hat. So this is just negative m j j hat, right? And the last term is just also zero because mgy, the derivative with respect to the z-axis is just equal to zero. So which means that we just proved that the gravitational force is can be written as the gradient of the potential energy, which means that the gravitational force is a conservative force. Also, for another forces, for instance, the elastic, you can also write the elastic force to this following form, and also the Coulomb force, if you're familiar with it. And okay, so let's move to featured on conservative force. So nganong i-emphasize man nga conservative force. Unsa day naa pumingong ko conservative force. Okay. So the object subject to conservative force will move from a point of higher potential energy to a point of lower potential energy. So okay. So let's print screen it again and discuss it into the paint so that we sabtan yung resultado. And okay, so muna siya. So ito na isa akong discuss. Velocity. Okay. So the object subject to conservative force will move from a point of higher potential energy to a point of lower potential energy. So okay, so consider this object as na akong gi-point out ganina. Okay, consider this object a block with mass m. So na kay block diri with mass m. So this is same as before. This is y equals 0. This is y equals y2, and this is y equals y1. So now, for instance, ako nang gigunitan ang block nga na ni mass m. Ako siyang gi-hold. So okay. So the question is, what if buoyan ko ning block na initially nasa point y equals y1, buoyan ako. So sa mahitabo. So of course, it will move. Gikan sa y1, kadlong maybe kadlong sa y2. Right? So y equals 0. Question is nga nang mag-move mo na dira. Okay? So accordingly, one of the features of conservative force is the object subject to conservative force will move from a point of higher potential energy. So to a point of lower potential energy. So what is the potential energy at point y1? So at point y1, the potential energy here is equals to u1, which is equals to mgy1, right? So and this point over here, the potential energy at point y2 is u2, which is mgy2. And we know that u1 is greater than u2 due to the fact that y1 is greater than u2. So due to the fact that y1 is much greater than u2. So the object will always move from the region of high potential energy to the region of lower potential energy. That is one of the feature of conservative force. So which means that kung nako'y object say kining mass m, ako ning gigunitan ang mass m nako. Nagunit ako ni of course pa siya. At the time nga ako na siyang buyan, dili na hitabo nga mulop. Musaka na siya pababaw. There's no way nga musaka na pababaw. And the reason nga hindi na musaka pababaw is that because the force of gravity is a conservative force, which means that the object must move from higher potential to the lower potential. Okay, so okay, so let's okay, so kung nakoy object karon initially at point y1, tinakuha ni siyang buyan. There's no way nga mo-move niya akong mass m padulong sa babaw. The reason is that the force of gravity is a conservative force. And conservative force, as I said earlier, will the object subject to conservative force will move from a point of higher potential energy to a point of lower potential energy. So this arrow is not the direction of much lower potential energy. So this is the direction of much higher potential energy, which means that the object will move so from there to there. So this is the direction of much lower potential energy. So that is some feature of conservative force. Okay, so um next is the total work done. So accordingly, the total work done in moving an object in a closed path is zero. Okay, so that is one of the feature of conservative forces. So okay, so let's let's draw it again some horizontal lines. Let's so ato ning abusaran ang atong gravitational force no. Okay, hindi lang sa atong paano maayo. I-discuss yung maayo nga force. Iwi siya. Okay. So now consider this object. The object, so nasa sa y equals 0 gihapon, this is y equals y2, and this is y equals y1. Okay, so from earlier, the work done of the work done is F dot dl, which is equals to u1, right? Minus u2. So the potential energy at point y1 minus the potential energy at point u2. By the way, so consider an object. So na si Mas M dere sa point y1. Now si Mas M sa point y1 nag-move siya from point y1 nag-move siya padung sa point y2. For instance, gikan sa point y1 to y2 nibalik na po siya sa point y1. So the question is pila ang work done? So from here, we know that at first ang iyahang gravitational potential energy is given by y1 minus y2. So nahitabo mag-plus na ta asa siya gikan? Gikan sa y2. So this is u2. Kasya na itong pa sa sunod minus y1. So this is just equal to 0. Right? Mag-cancel out ito na. So kung kung the total work done of conservative force in moving in a closed path is 0. In fact, bisan pag gikan ka sa y1, bisan pag ang displacement vector nimo is nag grabe ka gubot imong displacement vector, as long as nibalik ka sa imong gagyan, then kuhaon nimo ang total work done nimo. Yeah. So the work done is always 0. Bisan pag unsa ang displacement vector nimo, bisan pag unsa ka lukot sa imong gagyan nga dalan, as long as nibalik ka sa point kung asa ka gikan, pero nahimo siya closed path, then the total work done of the conservative force is always 0. Okay, so that's the point in the second picture. And lastly, the total mechanical energy of the system is constant. So let's discuss it. So let's first cut this one. Okay, so pasabot ana. So suppose mo niya ako ang this is y2 and this is y equals 0. Okay? Now, suppose na ay mas m dire. Karon si mas m nako karon is ako na siyang gigunitan. Gunitan ako. So kung akong buyan si mas m, according to the first picture, na move din siya paubos kay mo ang direction paubos, mo siya ang direction nga much lower ang potential energy, right? So karon question is at the time nga wala pa nako gibuyan si point at the time nga napagid siya mo gipagbuhi nako initially at rest di ba siya, so which means that initially at point y2 the kinetic energy the initial kinetic energy of the object subject to this gravitational force is 0. Right, akong siya gunitan nagpundo man siya, so now karon akong buyan si M2 kasi mahitabo ni M2 ni M sorry. So unsay mahitabo ni M kung ako siyang buyan? So mahitabo gikan siya at rest, maghinahini og kakusog iyang velocity. Right? As time goes by magkakusog iyang velocity. Pero unsay nahitabo? Kung magkakusog ang iyang velocity, ang nahitabo ang kinetic energy niya is musaka. Mo increase ang iyang kinetic energy as time goes by. But notice that ang iya pong height from the ground as time goes by is nagkagamay, which means that ang iyang potential energy is nagka-decrease such that ang rate sa pag-increase sa iyahang potential and kinetic energy is equal to the negative sa rate sa pag-decrease sa iyahang potential energy. Okay, that's a wrong statement. Ang rate sa pag-increase sa iyahang potential energy is equal sa rate sa pag-decrease sa iyahang potential energy such that the sum of kinetic energy plus potential energy is equals to constant. Okay? So, ang hitabo, there is some conversion of energy. So, ang potential energy is na-convert into kinetic energy. So, makita ninyo, at first, ang object is initially at rest, but grabe ka maximum. Max yung potential energy. Yung potential energy is maximum. So, as time goes by, mo siyang gibuyan, nahitabo, As time goes by, nagkadako ang time, nagkadako po rin yung velocity. Kaya nagkadako yung velocity, nagkadako yung kinetic energy. But as time po goes by, ang iyang distance from the ground is nagagamay, which means na yung potential energy nagagamay. So, the kinetic energy is increasing. Kung unsa ka kusog ang rate sa pag-increase sa iyang kinetic energy, mao po ang rate sa pag-decrease sa iyang potential energy. Such that ang sum sa kinetic energy plus sa sum sa potential energy is equal to constant number. Actually, this is what we call the mechanical energy. So, in the case of a conservative force, the mechanical energy, which is equals to the kinetic energy plus potential energy, is just equal to some constant. Okay, so let's have one more feature, one more example nga ma-feel ninyo nga mechanical energy na to is constant. And let's take the case of projectile. So, take itong case of projectile. Okay? So, suppose mali mo horizontal. Then, akay do ito na yung projectile. Okay? So, di siya projectile, no? Mati siya ang projectile. Okay? So, suppose guwapa na siya ang projectile. So, suppose imong object gikan dire. Gikan dire yung object. Imong gisipa ang bula. Gisipa na akong bula, soccer gano'n eh. Gisipa na ako. So, suppose na abot siya dire nga point. So, katataod na abot na po siya dire nga point. Okay? So, dire sa sugod sa pinakauna. So, tawagon na lang point A. Muna yung point A na ako. O kini muna ako ang point B. So, magsugod sa point A. So, sa point A, ang nahitabo karon is at the start. So, for instance, kining case, walay air resistance because air resistance is not a conservative force. So, for instance, i-neglect atong air resistance o gravitational force lang tanan. And, ano yung nahitabuan ni? Ang nahitabuan ni is that, sa sugod pa, yung pagsipa sa bula, kusog kayo mulagan ang bula. So, from the start, kusog kayo ang kinetic energy. So, dire, sa point A, kusog pang kinetic energy. But, ang height nimo from the ground is lower. Tawag ko Y1. Right? The potential energy at point Y1 is may right mas U1 which is equals to mgy1. Right? So karon as time goes by, ang imong bula naabot sa point B. Diri sa point B, dako kayo siya og kinetic energy. Ano no, gamay na kay siya kinetic energy. Kaya mo gamay mo na bula, mo hinay mo na pagdagan. But ang iyang height from the ground, which is Y2, is much higher than before. Therefore, ang potential energy U2, which is equals to mgy2, is much greater than the potential energy at point A, which is mgy1. So U2 is greater than U1. So nahitabo dire ang kinetic energy dire kusog, pero gamay po yung potential energy. Tapos ba niabot siya dire, hinay ang velocity, pero ang iyang potential energy is nindako. Kung pag-abot niya dire, so let's find another color. So pag-abot niya dire, kini nga point, this is the maximum. This is the maximum. Pag-abot niya sa maximum, ang hitabo, pila ang velocity along y sa maximum. So the velocity y, the vy at point h, right, is equals to 0. Which means that ang kinetic energy nimo, so we will denote that as key. Ang kinetic energy nimo along the y axis, so the kinetic energy is equal to 0. Right? Nihulong mo siya sa babaw. Pero ang iyang potential energy na is mo'y pinaka-maximum. So nahitabo ni increase ang imong potential energy as time goes by, pero ang imong pong kinetic is nagagamay. Pag naog niya, nahitabo, ikan siya sa By equals 0, yung kinetic energy 0, pero yung potential energy maximum, naghinahinay siya naog, nagagamay ang potential energy, pero yung kinetic energy is nagkadako as time goes by. such that ang imong mechanical energy, ME, which is equals to kinetic energy plus potential energy is actually equal to some constant. Okay? So, yeah. Okay, so I hope na nasabtan ko klaro. And next, let's move to next na topic. Okay, so let's move to problems involving both conservative and non-conservative force. So again, let's print screen this one. Go to the print screen and we will open this one. So okay. So for instance, na kay problem involving conservative force ug naa po'y non-conservative force. So for instance, na kay problem nga na siya resistance or maybe na siya friction. So unsaon na to pag emphasize na to ana? Unsaon na to pag-express ato ang conservation of energy. So if for instance, na kay work done, remember that the work done is equal to the change in kinetic energy. So, but in this case, suppose na ang imong work done is na kay duha ka source. This is a source sa work done sa imong conservative ug na kay work done sa imong so we talk to other. So other which means that other type of forces, non-conservative. So remember that if the work done of a conservative force, this guy over here, so the work done of the conservative force is just can be written as U1 minus U2 as discussed earlier. So we write this as W order. Okay? And now we can write this as, so let's arrange terms. So natay key E2. So key E2 minus key E1, which is now equals to U1. U1 minus U2 plus W order. Now we will arrange it. So may right of siya as i-plus atong iusa ang mga 1 tanan ug iusa atong mga 2 tanan. So may right ato is U1 plus KE1 plus W order. So transpose na akong KE1 ina akong balik ang pagsulat. W order which is equals to the U2 plus K2. Okay? So so in the case of a problem where there is uh, there is a conservative force and a non-conservative force, maybe there is some friction or there are a resistance. So the conservation of energy will be like this: U1 plus KE1 plus the W other is equals to U2 plus KE2. So okay, so now let's solve some examples. So solve the examples. Okay.